this lesson, you will find trigonometric ratios of angles and use trigonometry to solve right triangles. So all we're going to do today is just focus on right triangles. So first of all, what is trigonometry? It is the study of properties of triangles and trigonometric functions and their applications, and we're going to focus today just on the right triangles of trigonometry. Now, some facts about trigonometry. British surveyors measured the altitude of the peak of Mount Everest using trigonometric ratios. So these are used in the real world because we can't actually measure the height of a mountain, so we have to use the ratios of the right triangle that the mountain creates with its shadow. An official height became 29,028 feet using surveying techniques because in 1852, obviously, we didn't have a lot of technology to help us. Well, in 1999, they used GPS and measured it at 29,035 feet. So the math was not that far off. So we really want to make sure we understand the trigonometry because this is what you would use if you're an engineer or if you are going to do anything in higher math. You'll use this a lot in pre-calculus. So a trigonometric ratio is a ratio of the length of the sides of a right triangle. Now we're going to use sine, and you'll notice the sine key on your calculator is SIN. It's not sin, it's sine. And sine is spelled S-I-N-E on your calculator, it's just S-I-N. And what it states is for any acute angle A of a right triangle, the ratio of the measured leg opposite to the hypotenuse. And so what we say for sine is O over H for opposite over hypotenuse. Cosine is on your calculator COS, right next to the sine key. And cosine is for any acute angle A, the ratio of the measure of the leg adjacent to the measure of the hypotenuse. So what we use then is A over H for adjacent over hypotenuse. And then finally, tangent is the tan key. And tangent is for any acute angle A, the ratio of the measure of the leg opposite to the measure of the leg adjacent. So we do O over A for opposite over adjacent. So here's a way to remember it, SOHCAHTOA. That's how you say it, SOHCAHTOA. Sine, opposite over hypotenuse. C would be the cosine, adjacent over hypotenuse. And T is tangent, opposite over adjacent. So if you can't remember what the ratio is, you can just say SOHCAHTOA. SOHCAHTOA will tell you exactly what your angles are. So let's just find for A the three trigonometric ratios. So we want to find sine of A, cosine of A, and tangent of A. Now, before we can get going, we need to find the measure of B, and we can do that using Pythagorean theorem, which is what you did yesterday. So we have 9 squared plus whatever B squared is to equal 15 squared. And some of you are probably already thinking of a 3, 4, 5 and using that Pythagorean triple to kind of help you get it, and that's fine too if you want to do that. So 81 plus B squared is equal to 225, and then we take 225 minus 81, and we get 144. And we do square root of both sides, and we get B equals 12. And some of you already knew that B was 12 because you used that 3, 4, 5. So when we want to find sine of A, remember, so we want to do opposite of A. So this is angle A that we're focusing right here. So opposite would be right here, 9, over the adjacent, or excuse me, opposite over hypotenuse. So is OH. So opposite over hypotenuse is 15. And then see if you can reduce that 9 over 15. I'm just going to use my ABC key here. So my sine of A is 3/5. Cosine is adjacent over hypotenuse. So the adjacent is 12 to A. Right here, adjacent is 12 next to, and hypotenuse is 15. So that's 12 over 15. We see if we can reduce that. I'm just going to use ABC key, and I get 4/5. And tangent is opposite over adjacent. So remember, opposite right here of A is 9, adjacent is 12. So it's 9/12, which reduces to 3/4. So that's how you would find your ratios. A ratio is just a fraction of your sine, cosine, and tangent of one angle. So you try the example in your notes. Now, to find an actual degree cosine, that's what you're going to use your calculator for, and you have to make sure it's in degree mode. Mine is, it says a little DRG there. If you are not able to put it in that right mode, you can use your keys up here to kind of help you, and text me if you have any trouble. So I'm going to do cosine of 42, so I type cosine 42, and then I hit equals, and it gives me a huge decimal. So what I want to do is 4 decimal places. I do 0.7431, and then that is the ratio if the cosine is 42 degrees. Let's try another one. Sine of 31 degrees. I want to go to nearest 10,000, so that's 4 decimal places. So I hit sine 31, and that's 4 decimal places, so that would be 0.5150. So you try the examples in your notes. Solving the triangle is finding the measures of all the angles and sides of a right triangle. So here is my right triangle, and I want to find the measure of every angle and every side. So as you see, I'm going to have to find A, I'm going to have to find C, and I'm going to have to find angle A. Well, we always start with finding the missing angle because we know that the triangle is adding up to 180 degrees, and if I know that this is 90 plus 41, I know that this one has to sum up to 180 degrees. So when I add to find that, I get 49 degrees for A. So when I put 49 in here, I have 49 plus 41 plus 90, and that would equal 180. Now to find my missing sides, what I'm going to do is I want to find this opposite of A. So I can use sine, which is opposite over hypotenuse, or I can use tangent, which is opposite over adjacent. Now, if I use sine, I don't know my hypotenuse here. My hypotenuse is C, so I don't know it. So sine would not be good to use here. You want to use the ratios of things you know. Now, tangent would be great to use because my tangent of 49 degrees would be A, which is what I want to solve for, over 6, because this is opposite over adjacent. And so what I can do then is to solve for A, I can do the opposite of dividing by 6, which is timesing by 6. And on my calculator, if I just take tangent of 49 and then I multiply that times 6, I get about 6.9. So I know that the side at angle A is about 6.9. And you should be able to round to the nearest tenth on the lengths of your sides. So now I just need to find the hypotenuse C. Now there's a couple different things you could do here. You could use Pythagorean theorem because you have one leg squared and you have another leg squared to equal that hypotenuse squared, and you've done that quite a bit, so you could do that. Or you could use another trigonometric ratio where you are looking for a hypotenuse, and either one of those is fine. To find angle C, I'm going to use sine of 41 degrees just to practice the ratios. So this is 41 degrees. Sine is opposite of B, so that would be the 6 over that hypotenuse C. So this one's a little bit different. This one I'm going to multiply by C. So I'm taking C times the sine of 41 to get 6. So what I need to do to get C by itself is divide by that sine of 41. So I take 6 divided by the sine of 41. So on my calculator, I'm going to do 6 divided by the sine of 41, and that gets me for C about 9.1. So now we have solved for every bit of that triangle. So go ahead and try the example in your notes, and I'll use the notes to help guide you. A trainer sets the incline of a treadmill to 10 degrees, and you see that right here, and the walking surface on the treadmill is 5 feet long. So about how many inches is the treadmill from the floor? So we're looking for this height here. So which ratio would give me opposite of this 10 degrees over hypotenuse, that would be tangent, TOA. So we're going to do tangent of 10 is equal to h over 5 because it's opposite over the hypotenuse. I think I just told you that wrong. This is opposite over hypotenuse. That is not tangent. Opposite over hypotenuse is sine. See, I'm doing things to just see if you're paying attention here. This is sine opposite over hypotenuse. So opposite over hypotenuse, so it's sine of 10. Opposite is h, hypotenuse is 5. So to get this h by itself, we're going to multiply by 5. And on my calculator, I'm going to do sine of 10 times 5. And I get about 0.77 is the height. So this height right here, I think have it be in, oh, just stop.